Hello friends, I welcome you in lecture number 24 on hypothesis testing. In this lecture, we will discuss one more question on hypothesis test on population variance or chi-square test for population variance. First, we understand what is this question about. The percentage of titanium in an alloy used in aerospace castings is measured in 51 randomly selected parts. The sample standard deviation is S equal to 0.37. Test the hypothesis H0 population where standard deviation equal to 0.25 versus alternative hypothesis that population standard deviation is 0.25 using 0.05 level of significance. So here we are given this sample of 51 randomly selected parts, and this characteristic or the object under study is the percentage of titanium in an alloy used in aerospace castings. So they are considering n equal to 51 randomly selected parts, and they found that the sample standard deviation for this sample of 51 parts is 0.37, and using this sample data we have to test this null hypothesis that population standard deviation is 0.25 against this alternative hypothesis and level of significance is 0.05. First we write down given information. Given that they are considering sample of size 51, sample standard deviation is given to be 0.37 and level of significance is 0.05, and nothing is specified about the underlying population. So if we want to use chi-square distribution, we have to assume that underlying population is normal population. Assume that underlying population follows normal distribution, or we can simply write that underlying population is normal. This is required to use chi-square distribution, and they have already given alternative and null hypothesis. We have to test this null hypothesis H0, which is population standard deviation equal to 0.25 against the alternative hypothesis that population standard deviation is different from 0.25. So this is two-sided alternative, therefore we can say that this is two-tailed hypothesis test, and we assume that null hypothesis is true. So we assume that H0 is true, so that we can use sigma equal to 0.25 in the test statistic formula. Level of significance is given as 0.05, and because we have two-tailed test, we have to divide this area into two parts of equal area 0.025, that is alpha by 2 is equal to 0.025, so that we will consider 0.025 area in left as well as right tail, because this is two-tailed test. Now because underlying population is normal and we are considering a randomly selected sample from normal population, therefore the formula for test statistic is given by that chi-square test. So now we calculate value of test statistic, and it is chi-square equal to sample size minus 1 times sample variance divided by population variance, and we are having all these values, so we substitute them in this formula. Value of n is 51, so here I have 51 minus 1. Sample standard deviation is given, it is 0.37, and here we have to square that quantity. This is sample variance divided by square of population standard deviation. We assume that null hypothesis is true, therefore we can consider sigma equal to 0.25. So I have used my scientific calculator, and this numerator becomes 50 times square of 0.37, and that turns out to be 6.845, and square of 0.25 is 0.0625, and if I take division of these two quantities, I obtain the value of test statistic as 109.52. So this we have obtained using this test statistic formula. Whenever you are using chi-square test for population variance, you have to remember this test statistic formula, and here the assumption is that underlying population is normal. Without that assumption, we cannot use this formula, and the result says that if we are selecting a random sample from a normal population, then this quantity n minus 1 times s square over sigma square follows a chi-square distribution with n minus 1 degrees of freedom. Now in the next step, we will calculate we will find out critical values. So for that we have to use chi-square table. Let me remove this, and I have two-tailed test, therefore I will consider equal area in both the tails, and the degrees of freedom for using chi-square table is n minus 1. Here value of n is 51, so there are 50 degrees of freedom. Level of significance is given as 0.05, and because we have two-tailed test, we divide this into two equal areas of 0.025. And now we roughly sketch the graph of chi-square distribution, and we are familiar with graph of chi-square distribution. It is positively skewed distribution. It has a longer tail towards right side. This will go parallel to x-axis. It will never cross x-axis, and we are considering equal area in left tail as well as right tail. So suppose this much area is 0.025, and value of chi-square random variable is always non-negative. This is going to be chi-square 0.025, because we are considering area to the right side of this point as 0.025. Here also we consider the same area 0.025, and this point we have to denote this point by chi-square suffix alpha. So we have to decide that what is the area to the right side of this point to find out this suffix alpha for denoting this point. So now we know that area to the left side of this point is 0.025, and the total area under this probability distribution is always 1. Therefore area to the right side of this point is obtained by subtracting 0.025 from 1 minus 0.025, that is going to be 0.975. So this point or this critical value of chi-square distribution is denoted by chi-square suffix 0.975, because area to the right side of this point is 0.975, which we obtain by subtracting 0.025 from the total area under this distribution, which is 1. So now we have to decide these two values, 0.975 chi-square 0.975 and chi-square 0.025 with 50 degrees of freedom. So now we go for chi-square table. We have to concentrate on two values. One area is 0.025 we are interested in chi-square 0.025 and chi-square 0.975. Degrees of freedom is 50. So suppose we first find out this value. So I have to concentrate in this column and I will go down unless I obtain 50 degrees of freedom in this column. So I am going down in both the columns, and here I have to go up to 50, and I will take intersection of this row and this column. So they intersect at this point 71.420. That means this point, this critical value is 71.420. Similarly, we find out this chi-square 0.975. For that, we have to look below this column and up to 50 degrees of freedom. So we go down in this column now up to 50 degrees of freedom, and we find out the intersection point. So this is the intersecting point. So now you can see for 50 degrees of freedom and 0.975 area in the right of that chi-square 0.975 is 32.357. This is 32.357. We can say that area to the right side of this point 32.357 is 0.975 with 50 degrees of freedom. So we have obtained both the critical values. Chi-square 0.025 is 71.420. This is 71.420, and chi-square 0.975 is 32.357. Let me write here, this point is 32.357, and these shaded areas both are rejection regions. This is rejection region and this is also rejection region, and area in the middle is non-rejection region, and here we have taken values of chi-square. So now we can compare calculated value of test statistic with these critical values. Calculated value of test statistic is 109.52, and we can see 109.52 is greater than this value 71.420. Suppose we have somewhere here this, suppose this value is 109.52. value of calculated value of chi-square test statistic is 109.52, and it is to the right side of this point, and therefore we can say that we are in rejection region. So we can now write that here this calculated value of test statistic chi-square test statistic value is 109.52 is greater than 71.420, which is critical value of chi-square distribution with 50 degrees of freedom. That means we are in rejection region, and therefore the conclusion is we reject the null hypothesis. We reject the null hypothesis H0. So this is very easy. You just have to be careful that here we have two-tailed test. Therefore we are dividing our given significance level 0.05 into two equal areas of 0.025. To find out this critical point, we have to look for 0.025 area and 50 degrees of freedom. To find out this critical point, we have to look for 0.975 area, not for 0.025, because chi-square table gives us the critical values for the areas which are to the right of that critical value. Therefore, this is denoted by chi-square suffix 0.975, that is 1 minus this area. And once we decide the critical values, we are comparing calculated value of test statistic and we check whether it is in rejection region or non-rejection region, and we conclude that this is in rejection region, therefore we reject the null hypothesis. So this is very easy test, and this is known as chi-square test for population variance or hypothesis test on population variance. And here we are asked to test this null hypothesis against this alternative hypothesis, and we conclude that we reject this null hypothesis that population standard deviation is 0.25. We are rejecting this statement that population standard deviation is 0.25, or we can say that the sample data is not giving enough evidence so that we cannot reject this statement, or because we are rejecting this null hypothesis, we can say that population standard deviation is different from 0.25. So this is all about this session. I hope you like it. Thanks for